So the last time that we were together, we talked about finding the intersection between two planes. And the way that we did that was to get one of those two planes in edge view. So if we had a true length strike line on one of those two planes and we went perpendicular to that true length strike line, it made that plane as an edge view. And then we were able to find the intersection and project back. So today, if we want to find the angle between two planes, let's just say, I'll just pick a couple of the planes on here. Well, let's start with some 90-degree planes. If I want to be able to measure the angle between this plane and this plane, I need to see those both as edge views. Would you guys agree with that? So if they're in edge view, now I can actually measure the 90-degree angle that's included here. Any other view, it's going to be foreshortened or skewed. So I need to see the edge view of these two planes in order to be able to measure the angle between them. How do I find the edge view of the two planes? Well, the key is in this intersecting line. What is true about this intersecting line in this view? It's a point view. So that is how we will find the intersection between any two planes. We need to find the point view of the intersecting line. So if we take a look at any other planes here, maybe I want to know the angle between this plane and this plane. If I hold them to where that intersecting line is a point, I can now measure the angle between those two. So that is the concept of the day. We want to find the intersection as a true length line, and then we can do a point view of it. So let's try that again. There we go. Let's take a look at the slides, and then we can do one in AutoCAD together as well. So here I have two planes already solved for the intersection. Here's my intersecting line. Most likely there would have been some other view to help us get to this point, but nonetheless, here's our intersecting planes, and we've solved for visibility. So I want to take this intersection line, and we're measuring the angle between the two planes. It doesn't really matter if it's an elevation or if it's a horizontal plane or whatever, so you can come off of any view. And before I can have a point view of this intersection line, I need a true length of it, right? So I get a true length, then a point view. So I need to construct a view that gives me a true length of this intersecting line. So that means either out here to the left or right, I'm going to create a hinge parallel to this intersection line. Or it means out to the left or right, I'll create one parallel to this intersection line. Either one's fine. So let's say I create a hinge like so that comes off again parallel to this line. Now I will not get any edge views just yet over here. It's going to be two planes is going to be the end result. So if I project over both planes and the intersection line, I get something that looks like this. And then if I solve for visibility, I'll get something that looks a little like that. So you can see these have been converted to hidden lines since it's poking through on the other side. Now that I have a true length intersection, I can now create a hinge perpendicular to that, and both of these planes should be an edge view. So as I project everything across, there are my two edge views. And then finally I can measure the angle. So the angle that we're looking for is the acute angle between the two planes. So not the larger angle, but just the smaller of the two possible angles. So as you can see, not really any brand new concepts. We've been finding true lengths and point views for quite some time now. We're just doing it as an intersection line now. Yes, Donnie?
Larger, the acute of the two angles, right?
So you want to find the acute angle, the smaller of the two. So this one would be what, 1/16? So we don't want that one, we want the smaller angle. And it doesn't matter which side you do it on, they're the same, obviously. So let's take a look at that in AutoCAD. And as always, you guys can do one of these along with me, or you can watch. And the one that I'm going to start from a template is one that actually we pulled up last week. So if I go to New and Templates and Additional Files. Blaine, I think yours are set to drawing files instead of templates. It's nothing you did, but now there you go, additional files. And then it was intersection planes. Now we did this together last week, and we're not going to do it again. So last week we found the intersection by finding a true length strike line, and then projecting and then getting an edge view. And I've actually got those. If you saved it, great, you can use that one, but I've got a solution layer if you thaw that out and look up above. We've got the end result from that exercise. And it's up to you. I'm going to change the layers so that they show up a little better up on my screen, so I'm just going to window around everything and change them to the object layer, or object lines layer, and then escape. And then I'm going to change my two hinges to the hinge layer. Oh, go ahead and close it and took the drop down and thaw it out first. So we see a little slip. So hopefully this looks familiar to everybody. It's one of the ones we worked through last time. So again, the steps that we went through, we created, and I'll just show you again real quick up on my screen how we got to this point. As a reminder, we created in the front view a true length, that's not true length yet, but a horizontal strike line so that I could project up to the view up above. And then where that crossed, I drew back to A. This was my true length strike line. So we created a hinge perpendicular to that, which gave us plane ABC and edge view. Once we had that, we then took these two intersecting lines back, and that gave us our intersection points here. We projected those down, and then we solved for visibility. So that's how we got to this point. So now what I want to do is I want to create a view that is going to give me the true length of this line right here. That's my intersection line. I need a true length of that one. So again, it doesn't really matter if I come down and to the left or up. I'm going to go ahead and go up on this one. So I'm going to create a hinge line just out here in space. Shift right click parallel and make it parallel to this intersection line right there. Then I'm going to project each plane, and again you can do one point at a time. I wouldn't recommend doing all 6 at the same time. I'm going to do each plane at a time, so I'm going to do A, B, and C together. So here's point A perpendicular, point B perpendicular, and C perpendicular. So then I'll go 2 views back for my offset. So offset layer current 1, 2. So technically I can come down here to the bottom, or I can come over here. They both should be the same. I'll come down to the bottom. So again, I'll try to keep the order right. B is the closest, then A, then C. B, then A, then C, so that means B is here, A is here, and C is here. And I'm going to copy just the first part of those labels. I'm not going to worry about the suffixes for now. Since I am talking about intersections, it makes it more important to label so I know what's intersecting with what. BAC. So next I'm going to bring XYZ across. So once more I'll use my ray tool. There's Z, there's X, and Y. 2 views back from my offset. So it looks like Z is the closest, then Y, then x. So z, then y, then x. So I'll place some points. There's z, there's y, there's x. And once more, I'm going to copy some labels. So that one was z, and that one was y. And that one was x. And as usual, if I get away from you, I do have some solutions that you can look at any point in time as well. Switch those into the object lines there. All right, so now I need to bring my intersection line over. So I'll use my ray tool and take these two intersection points up to this new view. Go. And again, taking a look at what lines they intersect, this is line XZ and this is line XY. So they're going up to XZ and XY. So I'll draw a line, take this up to XZ, that would be right here, and to XY. So that is going to be my true length intersecting line. And on the exercises, I don't care if you label it TL or not. You can go ahead and label it to help you remember that's your true length line. But now to solve for my visibility before I move on, I'll take maybe this apparent intersection here, take it down. That's intersecting between BC and XZ. What does it hit first? It hits XZ. So that means plane XYZ is on top on this side of the intersecting line. So that means I trim out any ABC lines, and then on the opposite side I trim out any XYZ lines. So I should get something that looks a little like that. So now my last view that I got to create, again this is a true length intersection line. I want to create a hinge perpendicular to it. So I will set my hinge lines layer current. And I'll draw a line perpendicular to it. There we go. Then I'll project these across. So again, I'm going to do one plane at a time. If I did everything correctly, they should both be edge views. If not, I'm going to have to go back and check some of my projections. So looks like I got C, then A, then B. Alright. So if I did that correctly, those three should line up perfectly as a straight line. Let's connect the beginning to the end, change them to a brighter layer here, and yes. Looks like that one worked out good. So now XYZ. There's X. Oh, I already did XYZ. I'm sorry. ABC. That's what I need to do. So here's C. A. And B. No, I did do. X and C pretty much line up. That's what goofed me up. All right, let's try that again. I was right the first time. X, Y, Z. I did, yes. So I did go the other way. So what we should see is that the angles are the same, no matter which way we went. So offset time. X, Y, Z. Z is the closest, then Y, then X. All right, point, point, point. And again, if I did that all correctly, those should all line up in a straight line. And it does. Not this one necessarily, that's from the other plane, but this one should line up. So looking good. So then the final step then is to measure the angle between them. So I'm going to use my drop down and use my angular dimension tool and just pick the two lines. And again, we're going for the acute dimension, the one that's less than 90. So I don't want to see that one, I want to see this one right here, 87 degrees. So as Blaine was alluding to, my solutions, if you click the layer drop down, there's a solution 2 layer that you can thaw out. Now when you thaw that one out, I solved the same one, but as I said, it doesn't matter if I found the true length coming off of this view or off of this view, and this one I came off of the frontal view, so this is true length. These are my edge views, but as you can see, the angle between them is the same, no matter which direction I go. So let's take a look at the exercises for the day. We're going to finish up the intersection exercises. And do give me a moment to go through these before you get started on them. So we're going to do intersections 5, 6, and 7. So if we take a look at intersection 5, you are to find the angle between the two planes in each of these examples. So as we take a look at the first one, there's two planes. There's plane XYV and XYW. So the intersecting line between those two planes is XY. As we look at the front view, here's plane XYV, and then behind it is plane XYW back here. So XY is the intersecting line between these two planes. Do we have a true length version of XY?
Yes.
Yeah, this is parallel to the horizontal, so that's true length. So you really just have one view to create on this one. When you create the one view, you should end up with some sort of view that looks a little something like this coming off of it, because that's the peak, and then that's one plane and one plane, and you'll measure the angle between them. And I'll actually show you the finished product in just a moment too. So as we look at this one, we've got two planes, ABC and BCD. BC is the intersecting line between the two planes. As I look over here on the side, I can see plane BCD and plane ABC is hidden, it's behind it. Do I have a true length intersecting line on this one? Yeah. So that's parallel to the frontal. That's true length, so I just need to create a view perpendicular to that, one direction or the other. And again, I'm going to wind up with some sort of V-shaped view where I can measure the angle between them. As we look at this one, I've got two rectangular planes, ABCD and CDEF. Their intersecting line between the two planes is CD. Do I have a true length intersecting line?
No.
I don't this time. So you've got two views to create on this one. Your first view is going to be a view parallel to the intersecting line. That will let you find the true length intersecting line, and then one more view to create the point view. So I'll show you what this one looks like when it's all said and done here. You can even make note of the angles that you're going for, but again, make sure you do all the proper labeling. And it might get a little busy depending on which direction you move things, but again, got kind of a V shape on these and a V shape on this one as well. It's just you've got to find this view here with the true length intersection first and then go perpendicular to it. Now as you can see, I made a hidden line in here to represent the piece of the plane that we can't see. If you deleted it instead or trimmed it out, it's not a huge deal. That's fine too. We can still see where the points are, but you can also just draw in a hidden line instead. All right, so let's take a look at intersection 6. I ramp up the difficulty a little bit with intersection 6 because you've got several views to create for this one. So it's two planes. Plane ABC and LST, and you are to find the intersection between them. So the first thing you need is a true length strike line on one of them. Looks like LT is parallel to the horizontal plane, so LT up here is true length. So my first view is going to come off of there. to find the edge view of LST and the intersection, and then I'll project back to these two views. Once you've done that, then you'll have the intersection line that you can create a true length of, and then a point view of. So you've got 3 views to create on this one basically. 1 to find the intersection, 1 to find the true length of that intersection, and 1 to find the point view, and thus the edge views. So again, I'll show you what that one looks like when it's all said and done. This one is another one of those cases where one doesn't completely pierce through the other one. They kind of overlap a little bit. So something to watch out for there. And then the final one intersection 7. Going a little slow here. There we go. So in this case, we're talking about this piece that's on the front of this little steamroller here. And what we want to do is we want to calculate the angle between the planes. So this is actually really 2 problems in one. I've actually got the part, sample part over here that I had 3D printed. So we're looking at this part right here, and when you're looking at it from, this would be the front view. In the front view, this is vertical and this is vertical. As I look down from the top view, this is an edge view basically, and this is an edge view. So obviously this is coming up closer to your eyes than this one. And what you are to determine is the angle between the sidewall and the top, and the angle between the sidewall and the bottom. And they aren't 90 degrees. You might think that they would be 90 degrees, but if I hold these to where, let's look at the top. This is in point view and these 2 are in edge view. It's an obtuse angle, right? It's actually more than 90. And then if I hold it to where this is an edge view and the bottom's an edge view and this connector is in point view, then you can see it's an acute angle. It's a little less than 90. So your strategy then is to find the true length of this line and then find its point view, find the true length of this line, and find its point view. So if I am looking at the views that you're given the front view here, and again, this is foreshortened, this is further away from your eyes than this one, and then I am given the top view. If I created, this is an edge view, right? If I create a hinge parallel to this, won't I get the true shape of this surface? So it's an edge view right now. I create a hinge parallel to it. This is going to be in true shape. By definition, if this is true shape, aren't all sides true length? So then you can create one view perpendicular to this edge, maybe over here, and calculate the angle, and then create another view maybe over here, perpendicular to this edge. And again, I'll pull up the key here so you can see what I'm talking about. So again, create a hinge parallel to the side. That way this surface of DHCG is in true shape. And then in one direction, let's see, make sure I get these right. This one I think is perpendicular to this one.
So you did parallel first?
Yep, parallel to this, and projected everything across. And since this is a true length, I create this hinge perpendicular to that. That gives me the point view of HG, and that lets me measure ultimately the angle around here. And then over on this side, I created this hinge perpendicular to CD to find the point view of CD, and thus the edge view of these 2 planes. And then I can measure that angle as well. All right, so that's the plan for today. Again, we'll do the test on Wednesday, and then please bring your books on Friday. Let me know if you have any questions.